Hello folks, hello everyone. Thank you for joining and welcome on Making It Faster Talk. Since my Twitter account has like 100 followers, I don't consider myself as a celebrity. Feels right to introduce myself in 3 lines. I think that I'm a performance detective. I chase stability crimes for over 7 years for various partners and customers. And I blog about crimes, performance crimes, on my Making It Faster blog. My slides are equipped with QR codes that you can follow later on while watching the recording. So why are we here? Frameworks evolve, code base changes, technologies are born and decay over time. However, the foundational idea remains. We will have an easygoing talk on principles rather than exact implementation details. Some slides will have a lot of text and I would not ask you to read that whole. In case the words I'll be saying shall resonate with you, you can read them in a recorded version. The next few slides will be touching agenda topics, and the question to get started is simple. Should programs be fast and reliable? I would expect that you are already here listening to my talk, and I don't need to invest a lot of time convincing you and throwing some sort of general statements that downtime is a pain and can cost a fortune. Like for Amazon, it cost like 2.6 billion US just for 13 minutes. That slower sites lead to less conversion. And what feels to be natural for us, common sense, was proven by Google machine learning study. Slower site result in higher bounce rates and produce less conversion. And Google would bring less traffic to sites that are slow because performance would be included into search ranking. However, we are developers and we'd like to get something that is relevant for us. I would ask you to take a moment and recall any slow operation you have faced recently. Like whatever, just stick it in your head. Mine would be is waiting for Sitecore to restart after I recompile an assembly, right? I'll give you some time to digest that. It could be log into your mobile bank or whatever, basically. It's just the foundation for you to apply ideas further on just in your mind. I want you to be involved. So how many seconds spent in there? For me, it would be roughly 1 minute. And how many times a day I face it? Let's say 20 times when I need to rebuild an assembly. And it brings me to 20 minutes a day just waiting for Sitecore to start. Okay, the next one is how many people would use that application and experience same conditions as you do. Saying we have 4K developers in general Sitecores, like just out of blue. And then we need to multiply all the numbers that we got. 1 minute, 20 times a day, it results to, whoa, kind of lots of minutes. But that doesn't resonate in our heads, right? We need to convert it into meaningful number. 55 days of waiting spent each day for Sitecore to start. Just think about it, right? You might have seen this movie, Time, and it's all about that. So slow operations take the most expensive resource you and I have. By now, we should have concluded that software is at least desired to be fast, and the question is how to make it faster. The first step, logically, would be to know where it slows down. But how to understand why it slows down? Assuming there is a mechanism out there that can instruct each thread to report every millisecond which line of code it executes, then we roughly can understand which code takes the time. But okay, we found the code. How to figure that we can bake a better version that would be faster? Assuming there is a tool that does super accurate performance measurement with high respect to statistical confidence, whatever, in simple language, it can produce repeatable results. Then we'd like to understand why our version would be faster. Assuming there is a tool that can show how inner hardware is used, like processor can have multiple caching layers, operations can be memory bound, and so on. And what to do if the problem is outside our code? Let's say it's in a framework. We have the notepad and it can edit text files because text files store symbols and notepad knows how to format, structure, and encode info. Considering C# or .NET programs would arrive with intermediate language baked inside, there should be a way to change it, similar notepad, but only for C#. And yeah, as well as other few tools that would help us in our crusade. So let's make a short recap. By now, we should have defined the performance problem to be solved in our head. Like for me, it was slow Sitecore startup. And for you, it was just take a second to recall it. And why are we here? To make it faster, right? And the question has to be asked, how to make it perform faster? Here are the options on the board. Just read them through, pick whatever you prefer, what would fit you. Like previous speaker mentioned that we can always add servers and we can maybe top up CPU, cooling system, storage, add more servers, add additional caching layers, put servers closer to the consumer, install software updates, send apologies. Sorry, it works as it works. That's the world. That's the life. We can add indexes. We can remove indexes. We can switch from Solr to Azure. We can switch back and other stuff, right? I'm giving you a few moments to read that and apply whatever is close to you. Feel free to pick options that are not listed in here, but think that they're good. At this time, we have the problem. We have the list of potential actionable items to resolve the performance bottleneck. Then what we're gonna do, we will jump to popular investigation techniques, how to investigate the slowness. And we'll start with anti-patterns. First one is random change. It's super popular these days. How it works, you take any configurable setting with a loud name like prefetch cache size and change it one way. Next, you, as a professional, spread this statement that it helped multiple times with high level of confidence. Confident statement made by professionals spreads confidence around. You're going to be wondering, how come could it work when it didn't help actually? And this is the answer. Daniel is the guy who won a Nobel Prize for behavioral economics. In simple words, he found a series of bugs in our perception. So guessing is not a good stuff. Random changes unlikely help, and there is a zillion of settings that you can change. So nah. Another really popular one is blame someone else. So you are developing a system and you're likely talking to another system. And then you're saying, oh, there is another system that is slow. And you throw that blame to another team. Another team performs an investigation, figures out what the problem, and returns back to you the root cause. At the end of the day, you received the results without spending any time. But this will not work in case another team say no. And you have to repeat it, repeat it, repeat it. So yeah, blaming someone else is not our options we're looking at. Most popular stuff is streetlight anti-method as well. The story is like the guy stands next to the car at night trying to find something under the streetlight. And as one approaches him asking, like, what are you doing? He's like, I lost my keys. Can you help me find it? They are searching for a while next to streetlight. And after not finding it, one guy asks, like, you sure you've lost it here? No, I lost them near the bar. But why are we looking here? Because the light is here. And it is believed that Sitecore logs can answer any question on the earth. Like, why is Sitecore slow? Why it crashes? Whatever. All you have is just Sitecore logs. And the businesses or whatever believe that, yes, that's all you need to do. Maybe they can also give you Sitecore config, right? The next is traffic light anti-method. We have an advanced enterprise-grade monitoring system that costs billions of dollars. Should there be a problem, we would have already caught it. So our dashboard is green, there is no problem. It's like pretending, all good. No, that's not our way. So by now it was fun, jokes aside, but what is the right way then? It all starts with the problem statement, right? Because the problem that doesn't have a clear definition cannot be clearly solved. From subjective to quantitative, like recall your problem definition. Was it just kind of slow, or it was 3.4 seconds in average at peak load? I think it was closer to the first one. It was just slow without anything else. No random changes, please. After the problem statement is defined, we should land with the hypothesis what is happening. Hypothesis, for example, if we're talking about caching layer too small, then the prediction would be a large portion of wall clock time would be spent in reading data from database or from wherever instead of cache hits. So if we do the performance profiling round, we would figure that out. We would see that exactly that is what our assumption is. We will either prove it or no. However, analysis shows that cache scavenge kicks in, it logs cache, and that is the why. All further activities are postponed. You get wall clock high time spent. And then the hypothesis next is we enable cache key indexing, scavenge shall be faster and whatever. So you got the drill. However, the question remains, how do you land with initial hypothesis when they just tell you it's slow, right? You need to collect intel to narrow down the possible culprit list. Questions to ask, what makes you think there is a performance problem? Not from the blaming someone, but asking why, what's happened? For how long have anything changed? Can you express it's not like slow, but 5 seconds, 10 seconds times out after 60 seconds? Is it only you or other people? In recent performance hunt, there was a problem that people with a lot of AD roles were affected because they got huge cookies or whatever. So basically, these are the bits here and there. You collect the bulk of information that will help you further on. And that brings us to performance analysis methodologies. We'll be discussing about 3 today. The first one, use, is a good starting point for almost every investigation, as it arrives with action checklist what needs to be checked. Similar to emergency landing guide, right? Just what you do. So for every resource in the system, it's like CPU, RAM, network, database, DTU, you check first usage. For how long the resource is used. An example, CPU is above 80% for last hour or just for 10 seconds. Saturation, was it used for 12% over last hour or for 80+%? And E stands for errors. It could be any monitoring tool of choice, app in size, task manager, whatever. We are hunting for logical data. The example with 12% CPU was given because assuming the server has 8 cores and it's slow and 12 CPU stays constantly, it might be that one core is fully consumed and then other ones are doing nothing, like log statement in C# or whatever. The next methodology would be event tracing. Systems mostly operate by processing discrete events like CPU instruction, disk commands, whatever. And when we're operating with performance analysis, it's usually an aggregation of those events together, like per second or whatever. However, the devil can be in detail, specific data, specific time sequence of stuff. So we'd like to have a possibility to see the sequence of events, even with the data that method is called with. Like recall, I think lots of developers would do that whenever you want to know that your function is called with arguments, you would do log info. I am called with this argument like 5, 7, 8. That's the logical event tracing, right? And the next one is latency analysis. We have the slow operation overall time, and we'd like to understand where that's coming from. Here is the user request response, browser request, router, network, delivery. So a lot of layers are in here, right? Even if we're talking about simple network transmit between the user laptop to your server, a sequence of layers in there, and the distance is there. So if it is slow for a specific user, the slowness can be arriving from anywhere in this logical stuff. It might be not even from your app. That's the thing to keep in mind. That is when the latency analysis helps you a lot. So we have discussed 3 performance methodologies to get started with. And then the next question has to be asked. Assuming we can find the bottleneck, what it takes to write faster code to make it faster. I would suggest that we need to understand the ratio between operators and simple quiz for you. How many CPU cycles can be done upon looking for a file in SSD? So would it be looking for a file on SSD faster than CPU, or CPU will be faster? I'll give you a few seconds to think about it. And I will even give you a hint. Why does not that resonate in your mind? I give you an answer. But that is another thing that Daniel Nobel Prize winner figured out, that numbers that do not resonate with our understanding are pretty much useless. When I scale it to the seconds, if one CPU cycle is 1 second, then finding something can be up to 90 hours. And even if you're doing a network transmit to the server that is in different region, it can take 8 years of scale time. Sounds scary, right? So next time when you ask yourself, should I cache Solar responses? The answer would be, right? Or should we hold all the servers in one data center? Or, yeah, I think you got what I'm saying. Next question, what can be faster than spending a few CPU cycles? Because in that table of latency, CPU is the king, is the fastest one, right? What can be faster? Not spending it. The fastest work is work not done. But most important part, according to John Bentley, case study write efficient problems, that is the dude that added a lot to algorithms, right? He's basically one of the fundamental people in performance. Is, people hate me when I do this pause, clean design and implementation, maintainable modularity. I feel that you're not impressed, right? Why would that be? I need to explain, right? As system evolves, you'll need to change a lot of stuff. You'll get bottlenecks here and there. You change it in one place and it simply moves to the next one. Here is an illustration. There is a road and there is a fallen tree on it. And you think that this is my bottleneck, I remove it. Are you sure, or what makes you sure that this is the only tree on the road, right? So you'll need to change algorithm, databases, data structure, whatever, everything. The easier you could do it, the better, the faster you could. And the change should be safe. Remember, you don't want to break anything. The movie is Ford versus Ferrari. And here, Ken Miles, this guy, Christian Bale, Ken Miles, knows how to make car faster with every lap. He knows what is happening inside the car in every aspect, in every single moment. So how can we translate that into the performance itself, right? Dynamic profiling can show slow part, but there is still enough profilers out there. We need one that doesn't require installation, that is easy to use, doesn't introduce any overhead, and should be free preferably, right? And here is it. I have figured it out for you. This is the hand of the .NET compiler creator, performance architect, Vance Morrison. That is the guy that was constantly bothered that .NET framework is slow, is slow, is slow. And he wrote a tool to show that it's not the .NET framework. And on the video, you see that this is actually the screenshot from there. He's saying that Perf4U is the best tool to use. You could reasonably argue this is random picture, random head. How can I prove my statement? Boom, this is from Microsoft channel. You can watch this video later on. So are all above requirements met? Purview runs on event tracing mechanism that is kernel level from OS that allows us to log system events, turn them login on off, and potentially add own events into there, right? It's very easy to use. Just 3 steps. The first one is download stuff from the Purview Microsoft. Second one is you need to put it inside the server. And the third one is you click checkbox, 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 go. And you are ready for the performance profiling. I think there was a number of Docker-related topics in here, and somebody should have noticed something being wrong. It was a Docker compose, and as we know in Docker, you have no UI and you cannot start Purview. What do you do when you're a developer with zillion of years experience? You hope that Google will save you. And yes, it turns out that profiling can be launched with command line args, and it's quite simple. Purview, yes, I agree with your licensing. Yes, please let each thread tell what it does. For example, if the thread is not runnable on CPU, it's just waiting for a database to give you the response. Whatever you do, log it into the file. Do not rush to pack everything. Like if system has more important events, let it first and collect it for 80 seconds. And please use these provider IDs. What were those IDs? In the event tracing mechanism, there is a possibility to add your own providers, and there is a series of providers that arrive with the Windows, with the .NET, and so on. You can get the list of providers installed on the system by requesting logman query providers. Here are the IDs. You can use those IDs. Another gotcha. Event tracing is feature of OS, and in Docker, that's kinda different from real life or old school virtual machines. The good part is that, yes, it can do. This message is stolen from the documentation, and I was not able to find a way how can I put it to the screen. But in short, Windows can do that for at least few years, starting from 2017. So yeah, we're good to go. What we wanted to do is to launch the profiler. But nothing happens for us when we do the steps. I will ask you to read this with me. Containers don't have, okay. This means that if you run Purview from command prompt in a container, it will seem to do nothing, but it was doing something you don't see then touching. Huh, wonderful move. You start profiling and it doesn't seem to do anything, but it actually does. One of the requirements was usability. We don't want to read a lot of manuals to see how that profiler is supposed to operate, how to analyze stuff. That is where the performance in Purview and flame graphs becomes so easy to use. There is mostly one rule to analyze flame graphs. Ready for it? The wider bar, the more time is spent in there. So boom, it was application start for me. And this is the high level overview what happens during the start. So you could think that this is what you get immediately when you open it, but no, that's what you get. That happens because you see all the threads in this application in all states. You need to know the controls, how to zoom to information that you need. So first, we're interested to see only Sitecore stuff. You see the difference, right? It's more packed. Then we are looking for application start. And I want to include only frames that have anywhere in their application start. Then I would like to hide the noise, anything that is smaller than 4%. So if it's smaller, then please append this time to parent. And boom, here we go, right? Also, we have the bars. Each bar has the name of the method, and methods might be useless when they're wrapper, like dynamic class or core pipeline. And you could ask me, how do I know where wrappers or what is that, right? And I can tell you that assemblies arrive with IL code, and there should be a way how to restore that IL back into the C# to C. In our case, core pipeline does nothing but only invokes the processor that you have in config. That's why we can safely skip that from the view to get meaningful bits. Wait, but there is a mechanism to hide the code from being viewed. It's called obfuscation. So when you try to open it, what it happens, right? So the next thing I'm going to show is only for diagnostic investigation purposes, right? If you can obfuscate, then logically there should be a way around the obfuscate. And it's quite easy to use. You just drop it there, defuscates, and then it restores the view. So that is only for investigational purposes. In past, I've experienced an issue solely provoked by obfuscation. So the obfuscation was not safe in multi-threaded environment, and that was the way how to figure out that this is an issue. And it is important to use the same data as in real life, right? We found the long-running method. We can bake the code that looks to be faster, but we need to measure it with the data that is in real life. What is the data set? How can we figure that out? If only we could take all the data from live application and plug it into our candidate. In here on your left, you see the real world picture. On your right, you have application picture. Oh wait, it's the other way around. You cannot detect it from here because both files are just an array of bytes, and it's a matter of having the right tool to open it. Yeah. So what is it? If we look at the typical park picture, you will see trees, humans. You can count how many birds in there, or you can get the time when it was taken, what is happening. You can likely guess, but you cannot, for example, find the speed that the car is driving on the back, right? Exactly same with an application picture. You can see all object timestamps, whatever each thread does at exact point in time. However, you don't know for how much time it does that unless it has a special label that I do that for amount of time. Cool. How to make a memory snapshot? Easy. You just create dump file, and you can actually do it in Azure. You can do it in containers. Just the mechanism is slightly different, but it's still the feature of OS. You just freeze the process. You copy everything that is in memory and save it, right? And this is how it looks when you try to open the memory snapshot and see what objects are there. And you can reasonably argue with me that billions of operations are performed every second. How can we collect the data in the right point in time? So you need to raise a flag in the right moment when your performance problem happens or point in interest, which sounds like an exceptional situation. And there is a mechanism to capture memory snapshots when exception is thrown. But if there is no exception, like your application is running fine and you just need to capture the data it operates with, then you can raise one. How does it sound? Don't thank you. But wait, if it's inside third-party framework, then how it works. Good part is that we discussed that there is a way to edit text files, then there should be a way on how to edit assemblies as well, unless they're strictly signed or whatever. And that tool is called Reflexil. It's as easy as open and you edit the IL code. Are you supposed to write IL code by hand? No, we just had the method compiled in the previous picture, and you can just use that IL code and transfer it to the place of interest. Right? Done. Okay. And if I have zillion of objects in the memory, let's say cache has 40K entries, am I supposed to use Excel or whatever to copy everything from there and put it into the file? Nope. There is a tool from Microsoft. It's called Microsoft Diagnostics Runtime that allows you to write C# code to process the memory snapshots. On your left, you can see the object in memory, access result cache key, as an example. It has a few fields in here. And on your right, you have the crash file or the memory snapshot itself. And you enumerate of all objects that have type of access result cache key. And then you simply read fields by their types. You get the model. And I've saved that model to file. Sounds good, right? But what if I don't need an exact time? What if I want to know the sequence of calls for my method, the data it operates with, and I'd like to have it running for a few minutes at least. Wait, that is what we learned earlier about dynamic profiling per few providers, that you can add your own providers, that some providers are out of the box and you can create your own. What it takes, you simply reference the diagnostic trace and trace event stuff, and that is your event source. Just 2 lines of code. The first one is like your event. It's logcat for me. Yeah, I know. I have that time figuring out the name. And an instance of logger itself. And this is how you call it, right? Like simple example, I created log module. I added it into the Sitecore, and then whatever status code is 400 and its media request, I would log that information. As easy as that. And previously, remember that we were sending the providers to be used. And in here, I asked my provider to be used. What happens is it is enabled for 20 seconds and then stopped. And as a result, I can see when they were called, with what data, on what processor, and basically information I am interested. You can reasonably argue with me that, wait, purview, okay, I can see it in purview, but I need to aggregate that stuff. Am I supposed to do it by hand? No, again, you can use C# code for that. You have that event trace source, it is general purpose. Just find that is of your name and extract it by hand. So if I make a typo in here, it fails. Okay. There is another way around it. We have the collected trace. We ask purview to dump information about all events, and then we ask it to be automatically generated. And as a result, what we get is event source automatically created for us with strong typing. And it's actually the outcome of things with manifests. That is too much text. What we need to care about is that there is logman query providers command, and it gives a list. So when we have found our provider installed on the system, we can ask purview to dump that manifest and make auto-generated file in case we want to combine events together from Windows kernel file access or thread times with our stuff, or we want to do some sort of processing. To conclude, when it is needed, to trace data application operates with. Okay, so we have all the data right now. What are we supposed to do with that? As if we could get all the data, put it into existing code, candidate code, and figure out who's faster. And we have micro benchmarks. Benchmark.net helps us to do with that. There are a few problems with benchmarks in general. Unrepeatable results, as the processor can be busy with other activities like you're opening Visual Studio in background, you execute the code, and then it gets corrupted or inaccurate result. Because of that, and the code that is actually slower turns to be faster according to that. So it deals with that. Benchmark.net handles that by launching it for as much times as confidence level reaches. It also collects the information of system before and after to ensure that it was the even state. And this is how it looks for us. We were looking at access result, and then we deserialize it. We put it into the memory, everything from there, and we have better access result cache. And we have different containers to test, like benchmark 1, benchmark 2, and so on. When we execute it, what happens? We get a table that shows us exactly that if you add index, then you allocate a lot of memory. And when you don't add it, you allocate not that much memory. But then when you remove it, here is the difference, right? So in Sitecore, there is add cache key indexing, and here is the difference. In general, benchmark is as easy as that. You just create the method and run it. You can use it for testing your assumption when you just write the code, performance critical code. And Assuming we have figured out that our version is faster, why is faster? And there is a tool for that. It's VTune Amplifier. I would ask you to take a moment to look at these two files. They are doing exactly the same stuff. It is Sitecore counter implementation, and it checks if it is initialized. Then it basically all it does. And the original version takes 6 seconds, and then it tells it's badly memory bound. And if we jump to CPU analysis, we'll see that little of architecture is used. And that is our improved version. Same stuff is done much faster. So performance is like a chain, as strong as the weakest link. Every node of the system must be fast, otherwise you got it, right? If I could choose a single line for this presentation you could take away with you is, please do not jump to conclusion without technical facts. Here are the materials that I would strongly suggest you to look through if you're interested in performance stuff. All right, the materials. And thank you for staying with me and staying alive throughout this talk. I'm ready to answer your questions if anyone is still alive. Anybody here?
Any
Nobody's
questions?
here.
Yeah, not seeing any questions on the channel. Any questions for Nikolay?
Yeah, no questions.
Then thank you so much for listening to me. It was a pleasure to give a talk here. Have a great day, folks. Oh, no, we got.
We have a question.
Yes. Thank you, Mark. Yeah, I found a lot of improvements in Sitecore. And one of the coolest was when you don't know what is happening at first, and then you make an assumption that it is one thing, and it turns out to be completely different. The presentation, I've used materials from my performance crimes articles, and each of them is real life story about the cache scavenge, about the most CPU consuming operation inside core being counters. Recently, I've seen that 30% of request processing time is spent on log.info. It was just this week. So that can be considered as cool thing to think about.
Oh, nice.
Great. Thank you. See you.
Nice.
Bye.
Thank you so much.
Thank you so much.
Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.